Hello, in this video I'd like to demonstrate the polar alignment feature of the Mgen3 device. This method can be described as a digital supported form of the standard drift alignment method, also known as Scheiner method. This method is perfectly suitable for either improve your already polar aligned telescope mount or to do a polar alignment in such cases where you don't have sight to Polaris, for instance on your balcony or so. The second case is the one I'd like to demonstrate in this video, but before we start with the Mgen, we need to make some preferences. No worries, I'll go to all this step by step. Well, let's start with the tutorial. If you can't see Polaris, you should at least set up your mount in north-south direction. I did this here with my mobile phone on my balcony. This isn't absolutely necessary, but it saves a huge amount of time later. Also, I used a bubble level to level my mount, and again, this isn't critical, but it helps a lot and saves us time and frustration during this process. After setting up the mount on the tripod, I used this angle to set up for the right latitude. Your mount is now set up in north direction, shows the right angle for your geographical latitude, and you can be sure that your mount is at least roughly looking at Polaris now. You can now set up your telescope on your mount, set up your guiding scope and the Mgen3 auto guider, and after that we can finally start with the drift align procedure. The polar alignment of a German equatorial mount is always a two-step procedure. First, you need to set up the horizontal angle of your mount, and after that we set up for the right angle in height. To set up for the azimuth, we are looking for a star shortly before reaching the meridian and near the equator, which means a declination of ±0 degrees. Let's have a look how the telescope should be oriented to do so. Here you can see how the tube of your telescope looks like when oriented to a star close to the equator shortly before reaching the meridian. It's needless to say that you now should switch on the Mgen, which should already be focused so you can see stars in the display. But you don't start the one push feature like you would normally do, instead you will navigate to the polar align section. Here we need to make some settings before we start. First of all, choose the right hemisphere. If you're on the northern hemisphere, choose north, which is of course the default setting. As we are going to set up the azimuth, you choose meridian under sky position. If your guide cam is installed to a reflector telescope, you need to tick this box, but most of you will use a small refractor telescope, so leave this as default. Of course, you need to set up for the right focal length of your guide scope, and last but not least, we need some stars to start the process, so navigate to Star Search and hit Enter. After a short time, the Mgen has hopefully found some stars and shows a so-called multistar in the upper left corner, which is the sum image of all the stars the Mgen found. You can now hit Calibrate to do a calibration. The Mgen will now ask you to move the mount slowly towards east. You can use the left-right buttons to do so, or you simply stop tracking your mount for a second. After you did so, confirm with OK and we can go on. Now we can finally start our first measurement. Navigate to Start Measurement and hit the Set button to confirm. In the upper right corner, you'll now see the error in degrees or arcseconds of your polar alignment, and also in which direction you should correct your mount to lower that error. There is also a timer function that shows you how many seconds elapsed since you started the measurement. Wait at least 30 seconds to get a stable reading before you stop measuring. You'll need to get a feeling for how long you need to wait until those numbers are stable, but 30 seconds is a good starting point. You can now stop the measurement and turn the appropriate knobs on your telescope mount. Imagine a point in the sky where the polar axis of your mount peers through the sky. This imaginary point tells you in which direction you should move the mount with your azimuth knobs, whether left or right. My deviation was more than a few degrees off, so I moved my mount pretty much. In this case, it is very likely that the star moves outside the little preview window. If this happens, you need to navigate down to Search Stars and repeat the star search until the engine again shows a multistar in the preview. So in simple words, you repeat this whole process until the deviation is so small that the star keeps within the borders of the preview window. In that case, you don't need to start a star search and directly start a new measurement. As my deviation was pretty big, I needed to repeat the whole process a couple of times. After a while, you'll see some improvements in the deviation numbers. If you are close to the optimum, it's very likely that the direction readout switches from left to right and back again. This is a clear sign that you are very close to the northern pole. Always keep in mind, wait until all those numbers and directions stabilize until you turn your knobs again. 30 seconds is a recommended time span, but from my experience it could take as long as 60 seconds until you finally know in which direction you need to go. You can now go on and adjust the latitude of the mount, but before you do this, you need to move the telescope tube to another position in the sky. Again, we are looking for a suitable star near the equator, but this time it should be a star in east or west position. On my balcony, my side is better towards the east, so I decided to pick a star in the east. And this is how the telescope looks like, pointing to a star in the east, close to the equator. In the menu, you need to switch the position mode from meridian to east or west, whether your telescope is pointing. In my case, in the last moment I decided to go for west and rotated my telescope for some reason. I'm just saying this in case you are confused about what I'm doing here. What comes next should now be familiar. Again, you navigate to Star Search, and as soon as the engine has found some stars, the multistar appears in the preview window. Navigate to Start Measurement and confirm with the Set button, and again the engine starts with a reading. After a few seconds you will see the deviation of your latitude and all the direction, whether up or down, in which you should correct your mount. And again, you should wait at least 30 seconds to get a stable reading before you start turning some knobs. And again, you probably need to repeat this whole process a couple of times until you're satisfied with the accuracy of your polar alignment. And as before, it might be that after a correction the multistar has moved out of the preview window. In that case, you again need to redo the star search before you start a new measurement. I've repeated this whole procedure until I had a difference of just a few arc seconds, which is more than enough for the most cases. Of course, you can now start all over again to get a very accurate polar alignment, but this is up to you, and as I said many times during this video, even differences of a few arc minutes are good enough for the most cases. If you prepared your mount like I did in the beginning of this video, this whole process takes just a few minutes until you are good to go for imaging. Thanks for watching this video, which you hopefully liked, and see you next time.